In section 5.3, we're going to make the connection between the antiderivatives, or the indefinite integrals that we did in sections 4.9, and definite integrals. So we did find some actual specific things in the end of section 4.9, where we were actually finding position functions and such. So we're going to talk about the fundamental theorem of calculus part 2. We'll do part 1 next, but part 2 says that the integral from a to b of little f of x dx is equal to capital F of a minus capital F of b. So if we remember that the definite integral for us was what gave us the net signed area of a function. So what this is telling me is the net signed area of the function is I messed this up, this is f of b minus f of a. The net signed area of a function is the antiderivative evaluated at the endpoint b minus the net signed, the antiderivative evaluated at point A. So we have a 4-step process. One is going to be find the antiderivative of little f. And there's a key point here. We don't have to add the plus c, because if I add a plus c here and a plus c here, the c minus the c's will cancel. So in essence, we are adding a c, but we're adding the 0 c. Step 2 is we are going to evaluate it at big F of b. Step 3 is evaluate at big F of a. And then step 4 is we are going to subtract. So now we're going to use the antiderivative process to find the net signed area. So we will no longer have to use Riemann's sums to find the area. Now on your first test, there are going to be some questions that ask you to find, either use the left-hand Riemann sum, the right-hand Riemann sum, use the limit of a Riemann sum to find the area. You can use the fundamental theorem of calculus part 2 to check your answer, but on those specific direction problems, you need to use the specific directions in order to calculate it. Just like on your first test in calculus 1, there were some problems I asked you to use the definition of an integral, of a derivative, to find the derivatives, so you couldn't use the shortcuts to answer those questions. So I'm going to do some examples so that we can see how this works. My first example is going to be problem 31 on page 374. So 31 says I want the definite integral from 0 to 1 of x minus the square root of x dx. So step 1 is to find the antiderivative of this. So the antiderivative of x would be x squared over 2. This square root of x is x to the 1/2, so I'm going to add 1 to the exponent, which is going to give me x to the 3/2. Dividing by the new exponent, dividing by 3/2 is the same thing as multiplying by 2/3. And then I am going to evaluate this between 0 and 1. So my next thing is to do is evaluate it at f of b. That's this top number. So I get 1 squared over 2 minus 2 times 1 to the 3/2 over 3. Evaluated at 0, which is 0 squared over 2 minus 2 times 0 to the 3/2 over 3. and then subtract 1 from the other. So I get 1 over 2, which is 1/2, minus, that's going to be 1 minus 2/3. That's 0, and that's 0. So my final answer is 1/2 minus 2/3. The common denominator is 6, so I have 3 halves. No, I have 3 sixths minus 4 sixths, which is negative 1/6. Tell you on polynomial functions, most of the time when you evaluate at 0, you're going to get 0 for the bottom thing. But my recommendation is you always put the 0 in there because there's going to be some problems that when you put 0 in, you will not get 0. So all we're doing is we're combining section 4.9 homework, which is finding antiderivatives, and then we're substituting in numbers to find the actual values. So this is a lot quicker process than using left-hand sums, right-hand sums, midpoint sums, even the limit of a Riemann sum to find our answers. Next one I'm going to do is number 33. Number 33 is the integral from 1 to 9 of 2 over the square root of x dx. Remember, this is x to the negative 1/2. So I have the integral from 1 to 9 of 2x to the negative 1/2 dx. I'm going to add 1 to the exponent, which is going to give me positive 1/2, and divide by 1/2, which is the same thing as multiplying by 2. So I get 4x to the 1/2, and I'm going to evaluate this between 1 and 9. So evaluating at 9, I get 4 times the square root of 9. Evaluating at 1, I get 4 times the square root of 1. Subtract my answers from each other. Square root of 9 is 3. 3 times 4 is 12. Square root of 1 is 1. 1 times 4 is 4. 12 minus 4 is 8. And that would be 8 units squared. Remember, we are finding an area. And that is the net sign area. The next one I'm going to do is 43. Says the integral from 1 to 4 of 1 minus x times x minus 4 dx. The reason why I chose this problem is to remind you is that we do not have a product rule for taking definite integrals. So what we need to do is we need to turn this into something we know how to find the integral of, and we're going to do that by multiplying this out. So it's the integral of from 1 to 4. 1 times x is x. 1 times negative 4 is negative 4. Negative x times x is negative x squared. Negative 4 times negative x is plus 4x. I'm going to simplify this. 1 to 4. I'm going to put it in standard form, so I have negative x squared plus 5x minus 4. And now I'm going to take the antiderivative. So this is negative. Add 1 to the exponent. Divide by the new exponent. Add 1 to the exponent. Except I should have divided by 3 here, sorry. Add 1 to the exponent. Divide by the new exponent. And turn that into a 4x. We are going to evaluate this between 1 and 4. So I'm going to move over to the left a little bit. I'm going to put a 4 in for x for my first group. So I get negative 4 cubed over 3 plus 5 times 4 squared minus, when I put a 1 in, so that's negative 1 cubed over 3 plus 5 times 1 squared over 2 minus 4 times 1. 4 cubed is 64. 64, so I get negative 64 thirds here. That would be 4 squared is 16. 16 divided by 2 is 8. 8 times 5 is 40. Minus 16. This would be negative times a negative, so this would be a positive 1/3. Minus 5/2. Minus times a minus is a positive, so this would be plus 4. What I'm going to do is I'm going to combine like terms first. So I have negative 64 thirds plus 1/3 would be negative 63 thirds. And negative 63 over 3 is negative 21. Negative 21 plus 40 is negative 19, is positive 19. 19 minus 16 is 3. 3 plus 4 is 7. So I have 7 plus 1/3 minus 5/2. The LCD is sixths. So I end up with 42 sixths plus 2 sixths minus 15 sixths. 42 plus 2 is 44. Minus 15 is 29. So I have 29 sixths as my final answer. The level of fractions and evaluation work on this problem is the level that I would expect you to be able to do by hand. So this may be a type of problem that would be on the no calculator portion of the test. If it was on the calculator portion of the test, I would expect you to at least write this step down, and then you can do the evaluation in the calculator. What my recommendation is that you would come up with this number minus this number in the calculator as 2 separate steps, and then actually do the subtraction to come up with your final answer. Even if it's a calculator one, we are going to want our final answer as an exact answer as a fraction. So the homework assignment are just like the types of problems I did here, where you're going to find the antiderivative, evaluate it at B, evaluate it at A, and subtract the one answer from the other to come up with your final answer.